And another problem is very often I mentioned spin up. So I often say, if you want to provide a 5-day ahead forecast, you actually need to simulate 5 times 5 days. So what is that extra 0.5 days? It is usually called the spin up. To explain it, we can use toolbox as well. After the data assimilation step, observation data will be used to infer what change should be put to the 3D grid data. Say, as in this figure A, it is so-called balanced initial state. You can imagine this to be the grid data from yesterday's simulation run for today's initial time. Basically, after simulating 24 hours, it is in a pretty balanced state. And then observation data come in, and then the data assimilation algorithm infer that some water mass should be here. And then it is actually a statistical algorithm. And that algorithm says you should add water at some point in the space, and resulting the analysis data to be used as initial condition data, like this figure B. You will see that it is not realistic, but this is actually what will come out from the data simulation algorithm. So if you carry out a simulation of the dynamical core, you will see that some wave will be formed. This fluid mass will go out, and then after some period of simulation, these waves will be dissipated, and it's become balanced again. So we will know that what's happened in figure C is something not quite true, but present in the simulation. So this is what will happen in the spin-up period. Some erroneous wave will come out, and then you need to wait for such spurious artifacts to disappear via dissipation. Usually it takes several hours of simulation for this to be dissipated. So usually you use 12 hours for spin up, then that will be all right. And after these are gone, the similar data afterward can be regarded as what you can get from prediction simulation. Of course, the world is not perfect. Something cannot be recovered. There are some irreversible processes that will make the simulation afterward erratic. It is like precipitation. If in the spin-up period, there are erroneous clouds formed, and then the erroneous clouds make the simulation have some precipitation to some area that doesn't really happen, and then the land may be cooled because rains are usually cold, and also the distribution of moisture in the atmosphere will be worsened, and these events are actually reversible. So the simulation afterwards is also bear this kind of error.